7.3 notes, multivariate linear systems and row operations.
Multipass. Have you ever seen the fifth?
The sixth sense. You have 5 senses.
Dang it. Never mind.
Okay, let's just go with the notes.
Let's do.
We're going to solve systems with more than 2 variables.
The fifth element.
And, no, I haven't. Okay, and we're going to do that a few different ways. We're going to start off here with elimination. So this problem,
brush off your algebra skills.
Yeah, this problem here, 6x minus 5y minus z equals -2. And then we continue on. When we eliminate, that's where we're trying to add 2 equations together so that a variable goes away.
Right. We're going to eliminate a variable.
Right.
Yes.
And with 3x3 kind of situations like this, typically it doesn't matter which variable we eliminate first, but in this case, it actually will be helpful if we look at this middle equation. It's missing a y.
Hey, so let's try and dump the y's.
Right. And in fact, if you look, the y's, all you have to do is add these 2 equations together, and you'll eliminate the y's.
Looky there.
So let me set this up. I'm going to take the first equation and the third equation. And these can get kind of long, just a spoiler alert.
You'll need some paper. It's quite possible you'll need some paper.
Okay, so we're adding these together. It gets rid of our y's. 10x plus z equals 14. Okay, now normally we would have to do that again now and eliminate y again. But
right.
This other equation already has y eliminated for us.
So we can just dive right on in.
Right. Write it underneath. And, whoa, this even has it set up.
Hey, man, what a great question to start with.
So these 2 add together and get rid of our z's. So that's 7x equals 14.
Oh, looky there. And it comes out nice.
So x equals 2. Now, you take that and you plug it back in someplace where you have 2 variables. So we have 2 variables right here and right here. So either of those equations would work. It doesn't matter which one you pick.
You're basically working back up from where you were. So we worked all the way down and eliminate all the variables until we just have one. Now we're going to go back up, because if we try and substitute the 2 into one of the problems,
like the first
or third one, we still have 2 variables left to deal with.
Yeah. So here I am solving for z once I plugged in x. So z equals -6, and now I have x and z, so now I go back to one of these original
Back up one
equations.
more.
So it doesn't matter again, so I'll pick the first one, 6 times x, which is 2, minus 5y, minus z, which is -6, equals -2. So that's 12, which will write down 12 minus 5. -6 is really a +6. So that's 18, adding like terms. Subtract 18. -5y equals -20. Divide by -5.
And you get
Y equals 4. And the way you typically will want to write this is as a 3-dimensional point. That's what this is talking about here. 2, 4, -6, which is x, y, z. So just like a point x, y.
X, Y, Z.
We can have a 3-dimensional point. That's what this kind of problem could be representing, as a 3-dimensional problem.
Right.
And that would be 3 lines where this is the point where those 3 lines intersect.
Right. Same rules apply here too. If you get like some wacky thing like 0 equals 4 or
0 equals 0.
Or 0 equals 0.
You have a special case.
You have a special case, and those are both okay to get.
Yeah.